All right, so I think we can start. It's right around 4. Let me know in the comments if you are having any technical difficulties. This is the first time I'm giving a talk on a platform like this. So yeah, let me know if you run into anything, and I'll keep an eye on the comment section as I talk and try to correct it from there. So you're at the talk, how to render 20,000 rows without crashing Chrome. I want to give a brief thank you to our sponsors who enabled this conference to happen. It's really cool to still be able to have this conference even with everything that is going on in the world, so a big thank you to them. I want to tell you a little bit about myself. My name's Lydia, and I'm a software developer at Atomic Object. We're based in Grand Rapids, Michigan, and we build custom software for a wide range of customers. And today, in this talk, I'm here to tell you a story. My story is about how I crashed Chrome. So the project I was working on had thousands of products that we wanted to display in a table. So I was experimenting with how to display all those products in a table. And in one of my first attempts, I was storing a lot of those products in client-side memory. And because of that, Chrome ran out of memory, and I ran into this beautiful page and crashed Chrome. So this talk is about how to not do that, how to not crash Chrome. And it's about how, instead of crashing Chrome, how to display huge amounts of data in snappy, responsive tables. So this talk has 3 parts. I'm going to start by focusing on the front end and talking about how you can render only the elements that the user sees, which is called virtualizing your data, but only re-rendering elements when necessary for snappy front-end performance. Then I'm going to jump over to how you can fetch data incrementally. This is also called just-in-time data loading, and how that will help you with performance. And then in order for us to do the second point, so to do just-in-time data loading, we also have to have a backend that supports pagination. While I'm going through this, I'm going to be using this example. This is a little example that I built using React on the front end and GraphQL and Node and TypeScript on the back end. Some of the things I talk about on the front end will be a little bit React specific. I'm going to talk about some React specific libraries, some React specific performance considerations, but the general idea should be applicable whatever your tech stack. And then the back end, very little of it has to do with it being a GraphQL backend. So what I talk about on the back end, as long as you're using some kind of relational database, should be applicable pretty much whatever type of backend that you're using. I want to caveat this with, there's a lot that goes into just-in-time data loading. I worked on this probably for about a month on my current project, getting everything right, getting the UI exactly how we wanted it. So because of that, I'm going to have to, in some aspects of this talk and some areas of this talk, go over fairly complicated technical implementation things at a fairly high level. But at the end, if you are actually going to try to implement this, I have linked some blog posts. So hopefully this talk will give you a general idea of how we set it up. And if you want specific implementation details, feel free to reach out to me after this talk or to look at the blog post that I link at the end of this talk. So I'm going to start by talking about the front end. So I said there are 2 main things to keep in mind when you're doing infinite scrollable tables on the front end. One thing is only render what the user will see. Don't try to render everything all at once. And the other thing to keep in mind is don't unnecessarily re-render components. So let's look into this a little bit. So throughout this talk, I'm going to be using an analogy of clothes shopping. So when you go clothes shopping, often you can only take a certain number of items in the dressing room with you. So say I went to the store and I had 10 items in my cart. I might only be able to try those items on 4 at a time. So instead of taking all 10 items that are in my cart and putting them in the dressing room at once, I would only take them in 4 at a time. So I would try on 4 items. When I'm done trying those on, try on other 4 items. So instead of bringing everything in all at once, I'm only bringing in the number of items I can easily try on at once. So basically, I'm virtualizing my clothes. So I'm trying them on in small chunks instead of trying on this whole chunk of clothes at once. I'm trying on this small chunk of clothes and then this small chunk of clothes. And this really isn't that different from what we want to do on the client. When we virtualize data on the client, we're not rendering all elements at once. Instead, we're rendering only enough elements to fill the screen. So if you look at this example, when I initially load this table, I'm only going to render this chunk of elements where the gray box is my screen. And then when the user scrolls down, I'm going to render this chunk of elements where the gray box is my screen. So this is virtualizing or windowing, and it's rendering just enough data to fill the viewport or the screen. And this is important for a couple of reasons. So this means that when you initially load the page, there's going to be less rendering work. And it also means that you will have fewer DOM nodes that are outside your viewport. And because you have fewer DOM nodes, you basically are using less memory and have a more performant application. And then as the user scrolls down the list, you'll be recycling those DOM nodes. So I would have like 5 DOM nodes here. And then as the user scrolls down, I would replace those DOM nodes with these new DOM nodes. But I would never have all these DOM nodes being rendered on the page at once. So let's actually look into this a little bit. So here is my example, and I'll make this full screen so we can see it better, and I'll even put it to the side. So let's inspect the elements on this page and look at what DOM nodes are getting rendered. So if I inspect this, you'll be able to see that there are a whole bunch of divs on this page. But one interesting thing is if I scroll down, there's only a couple divs outside of the table that are being rendered. But most of the divs that are being rendered are inside the table. This one extra div at the bottom, that's actually a row that we're overscanning. So it's a little bit of a trade-off when you decide how much rows you want to render, because having this additional row at the bottom means slightly better performance when I scroll quickly, because I'll already have a row that's loaded. But the important consideration here is like I'm only rendering 1 or 2 extra rows instead of having like all my 200 rows being rendered on the page at once, which that would happen if I wasn't doing any virtualizing. So then as I scroll down, you can see these divs. I have the same number of total divs. The old divs are going off the page and I'm getting new divs. So that's virtualizing my list. I'm not rendering everything all at once. Another important front-end consideration when doing infinite loading is not unnecessarily re-rendering components. So basically, we wouldn't want to render, say, row 3 here, and then when the user scrolls down, re-render row 3. We would only want to render it once, and as you scroll around, if you're still looking at the same row, it shouldn't re-render. And if you're using React, there are lots of really good tools to figure out how much you're rendering things. I often use the profiler. So if I go to the profiler, basically you can click record, and then I'm going to scroll around and then click stop recording. And then each of these things, if I click on this grid, so each of these things up here is a commit. And a commit is whenever React applies changes. And if a commit shows gray, it means that there is no changes for that component that render. But if it shows a color, it means that that component re-rendered for that render. So if I look at my grid, and if I look at these grid cells, for instance, I can tell that these grid cells didn't have to re-render for that commit. And if I click around, I'll see, like, this is a really interesting example in that all of these grid cells didn't have to re-render, but only the new grid cells, so the grid cells on the bottom, had to re-render. So basically that means these grid cells, I was reusing the old ones I had already rendered. So to do this in React, I won't go into all the nitty gritties, but you basically have to have a good memoization function because as long as for each of these cells, if you're memoizing it correctly, it shouldn't unnecessarily re-render. But if you don't have a good memoization function, then as you scroll up and down the grid, your cells will be re-rendering all the time, which leads to not so great performance. So whatever front end you're using, if you're using React, if you're using Angular, that's just something to pay attention to is like as you're scrolling up and down this grid, are these components re-rendering unnecessarily? So I talked about two considerations to keep in mind when you're doing just-in-time data loading on the front end. So now I'm going to jump a little bit into the implementation. This is a little bit React specific of how we did this on our project. So we use a library called React Window, which actually did a lot of this work for us. So React Window provides two UI components. Well, it provides quite a few UI components, but the main two we used were list and grid. And these components are very smart components. The list component renders rows necessary to fill itself based on a vertical scroll position. So basically, the list component that React Window provides is set up to let you window vertically. And React Window also provides a grid component. And the grid component renders the cells to fill itself based both on the horizontal and vertical scroll position. So this means that it can window both vertically and horizontally. So digging in just a little bit to our implementation of this, I'll make the font size a little bigger in this. So this is the component that we used from the React Window library. And this component has a couple interesting attributes. All the stuff here is just configuration. So this right here is what renders the table over here. It says like what the height of the table should be, what the height of the row should be, stuff like that. But two really interesting considerations for this component is, oops, right here. So two interesting parts of this is a callback that's invoked whenever a new grid section is rendered. So basically, this takes a callback, and this callback will get called whenever I scroll around the grid. So as I scroll around the grid, this callback on items rendered will get called, and there's a console log here. So if I go back to my terminal, and as I scroll around the grid, I'll see that this console log is getting invoked with my start index and my stop index and my overscan stop index, which is my stop index plus the couple of extra rows I'm rendering. So basically, this means that whenever I scroll around the grid, I'll invoke this callback. And then one other interesting prop that this fixed size grid takes is a prop. It's a render prop, basically, that says how to render the content in this cell. So if I go to this render prop, this render prop takes a row index, a column index, and a style. And it's responsible for figuring out what to render at that row, that column, and that position. So let's try, what if instead of returning what we did return, what if we just always returned hello for the cell render? What would happen? So as you can see, all of our cells got stuck over to the left. And that's because we are not applying the absolute positioning that we need to put these cells in the right place in the grid. So I'm going to go back and I'm going to add this style is basically has the absolute positioning that we need to get the cells in the right place, and then React Window will take care of putting them all in the right place. So great, we have the word hello rendered in the correct place. The two other bits of information that we have is the row index and the column index. So let me just print those out. So I know here's the row index, here's the column index. So I'm printing those out, and now I can see, okay, I know my row index and I know my column index. I'm just printing out hello row index, column index. But is what I really want is I want to be able to render some data that is useful to someone in this grid. So how would I be able to render some useful information here? So because I have a row index, a column index, I somehow need to get an array of data on my client that then I can use the row index to index into to get the correct row, and the column index to index into to get the correct column in that row. And then I can use those things to get the data I need to render for that cell. So I'm going to put this example back to what it was. And let's go back over to the slides. So if I want to have that data and be able to index into that data client side, I'll need to be able to fetch that data somewhere. And that brings us to the second point, is I want the functionality to fetch some data incrementally, to say, oh, I don't have this data structure I need yet to render content in the cell. I want to be able to go and get that data. So let's go back to the clothing analogy. So last time we were at the clothing store, we were saying we could only bring 4 items into the dressing room at once. So you would put 10 items in your cart, and then you would try them on 4 items at a time. But what if instead of trying on a total of 10 items, you wanted to try on a total of 100 items? Like you wanted the perfect Zoom appropriate top. So would you gather all of those 100 items at once and put them all in your cart at once? Probably not, unless you wanted to walk around the store looking like this or having a super full cart. And it might be the case that your cart isn't even big enough to put those 100 items in at once. Instead, you would want to put 10 items in your cart and then try those on, and then put another 10 items in your cart and then try those on. So that's basically just-in-time data loading. So you want to fetch things in chunks, like 10 items, try those on, and then fetch another chunk of things. And this is pretty much the same thing that I'm doing on my application. So instead of fetching all the data from the server at once, even if I had great front-end performance, that would still be a lot of data to get at once, and it could have a really, even completing that request might take a while. So instead of doing that, I want to say, can I have, say, the first 5 rows? Get the first 5 rows, and then say, okay, great, I have the first 5 rows, now can I get the next 5 rows, etc. You get the idea, get the next 5 rows. And it might not even have been possible if I didn't ask for the rows in chunks like this to store all those rows in client-side memory at once. So this enables you to work with data sets of like 20,000 rows that your client application couldn't handle necessarily, but because you fetch it in chunks, you're able to get the exact part of the data that the user needs. And this ties back to the title of my talk. So in one of my first experiments with this just-in-time data loading, I was doing some things right. I was virtualizing on the client, and I was even doing some just-in-time data loading. But as I was getting new rows, I was storing them all in client-side memory. And through this, I learned that it is possible to use up all the memory in Chrome. So I was storing so many rows in Chrome memory that Chrome memory eventually filled up and Chrome crashed. So main takeaway, it is possible to definitely fill up application memory with huge amounts of data and crash Chrome with that. So now that we know what we want to do, we want to just-in-time load data. How did we do that in our project? So jumping back over to where we were looking. So here is the grid that we're rendering on the front end. And then we use another library along with this grid. So we use this library called Infinite Loader. And this library was designed to address this problem. It is designed to incrementally fetch data, and it is also designed to be used with these grid on list components so they fit together really well. And it basically helps you break down large data sets into chunks that can be just-in-time loaded as the user scrolls down. So there's a couple props that this component takes that are interesting. So it takes a isItemLoaded prop that, given a row index, it's a callback that returns true or false. So if I scroll down to this grid to say row 20, when I render row 20, this isItemLoaded is going to get called with the row index 20. If I have the data I need for row index 20, it'll return true. But if I don't have the data I need for row index 20, it will return false. If it returns false, then this callback, the load more items callback, will get invoked. And the load more items callback is basically responsible for knowing how to get the data that I need. And then this infinite loader takes a child component. So the child component of this infinite loader is a render prop that takes onItemsRendered. And this onItemsRendered should be called whenever a new section of the grid is rendered, which fits really well in grid provides us a callback that is invoked whenever a new section of the grid is rendered. So you can tell that these are kind of meant to be used together. So basically, the whole workflow is when I scroll down the grid, this onItemsRendered is going to get called with the new section of the grid. Then infinite loader is going to be like, oh, a new section of the grid was rendered, and it's going to invoke the isItemLoaded callback, which is going to check to see if I have the data I need for that section or not. If I don't have the data I need, then it's going to call this load more items callback, which goes to the server to get more data. So that brings us to the next point. How does the server give us more data? And after we talk about the server, we'll go back and kind of circle back to this front end and how everything ties together. But let's jump over to the server. So in order for, on the front end, us to be able to load more data when we scroll to a new area of the grid, we have to have a backend that supports pagination because we want to be able to fetch data from the server incrementally. So let's go back to the clothing store. So last time we talked about the clothing store, we said we would prefer to have multiple cartfuls of 10 items instead of one cartful of, say, 100 items. But where do these items come from? To get these items, you walk around the store and pick up the items that you like in the rack and you put them in the cart. If the store didn't exist, you wouldn't be able to put these items in the cart. So basically, the racks in the store is where you go to find things to put in your cart. And the store has all the clothes, then you put a subset of these clothes in your cart, and then you try on an even smaller subset of those clothes. So just like the store is where you go to get a subset of clothes you want to try on, the server is where you go to get a subset of the rows you want to render. The subset of rows can also be called a page of rows. And pagination, like pages in a book, separates the data into pages. There's a couple of main types of pagination. There's offset-based pagination and cursor-based pagination. GraphQL Docs recommends cursor-based pagination, but I'll give a quick summary of both for comparison. So offset-based pagination, in offset-based pagination, the client asks for count number of rows starting from an offset. And the offset is the number of records you want to skip before selecting records. So for example, in offset-based pagination, I would say start from 0 and give me like count number of records. So give me 10 records, say my count is 10. And then I'd say, okay, start from 10 and give me another 10 rows. And then my offset would be 20. And then I'd say start from 20, give me another 10 rows. And my offset would be 30, etc. In cursor-based pagination, instead of asking the GraphQL server for count number of rows starting from an offset, we ask the server for count number of rows starting from a cursor, where a cursor is a unique identifier for a specific record. So for instance, here we're saying, give me count number of rows, but in our first request, we wouldn't have a cursor yet. So then we say, okay, give me 5 rows. I don't have a cursor. And then the server comes back to us and it says your start cursor is A, because that's the unique identifier for the first record. And then the end cursor, which is in my implementation, is the unique identifier for the item right after the last item. So F is the unique identifier for the item that comes after 4, so it's the unique identifier for 5. And now that we have an end cursor, we can make another request. And in the next request, we use our current end cursor as the start cursor. So we say, okay, my start cursor is F, give me 5 rows. And then it will use the F identifier to find record 5, and then return another 5 rows along with the end cursor. So then on my next request, I'd say, can I have another 5 rows? My start cursor is K. So why will we use cursor-based pagination? There's a couple reasons GraphQL docs recommend it. So first off, cursor-based pagination is more efficient. So in offset-based pagination, the database has to scan all the records up to the offset account, and then it discards the records up to the offset. So basically, as the offset increases, offset-based pagination suffers. But the performance of cursor-based pagination stays constant as the offset increases because the database doesn't have to read the rows up to the start cursor. It can just start at the start cursor. It doesn't have to read all the rows that come before that. So that's one reason to use cursor-based pagination. It's slightly more efficient. And then the second reason to use it, this wasn't really a big consideration on our project, but one reason GraphQL docs recommend cursor-based pagination is that if you add or remove items from your database, in offset-based pagination, you could have issues in that the same item is returned multiple times, skipped, but in cursor-based pagination, that's not as much of an issue. Because in cursor-based pagination, you have a start cursor, which acts as a pointer to a specific record. So you no longer have to rely on the fact that the position of the records before that remain the same. So if we look at this example, if these were the rows, the initial rows that came back, but if I were to say, add a row between my first request and my second request, if I were to add a row, the offset of everything would get messed up. So after I add a row, the offset of like F would go from 5 to 6, 6 would go from 6 to 7. So the offset would get all messed up. But if I'm using cursor-based pagination, my offset, I wouldn't have to worry about it because I have a pointer to this record here. So I can basically do anything I want up here. It's like a linked list. You can do anything you want basically to the nodes before the node you care about, and it will still return the correct stuff. So that's a couple of reasons to use cursor-based pagination. In our next slide, I'll get to some of the limitations of it. So if you're using cursor-based pagination, you have to have a cursor that's unique, sequential, and the thing that you sort by. So it's up to you how you're going to generate a unique identifier or a cursor for a specific record. Often a database column is used to generate a cursor. And if you use a database column, you have to use a database column that's unique and sequential. So like a auto-incrementing ID or a timestamp. One consideration, though, is you also need to sort your data by this column. So in this example that I walked through, I'm going to be using this is the employee table, and it has a created at date. And I'm going to be using the created at date as my cursor. But if you wanted to use something that was a non-unique column as your cursor, say you wanted to sort by like name and then email, you would have to combine multiple columns into your cursor, which gets a little bit messy. Or is what you could do is you could abandon cursor-based pagination if you wanted to do more complex sorting things and switch over to offset-based pagination. That's what we ended up doing on our project. Is we just had a lot of complex sorting logic, so we used offset-based pagination. So either one of these is definitely tenable. It just depends on what type of data you're working with and what your constraints are. But for the rest of this talk, I'm going to be, my example is based on using cursor-based pagination. So now that we've talked a little bit about pagination in general and how it works, and why you might use offset-based pagination or cursor-based pagination, let's talk about what we actually want our server to do. So we want to be able to, if we're using cursor-based pagination, say, hey server, here's a count of the number of records I want, and here's my start cursor. And in response, it should return the count number of rows, and then it should return information about the chunk of rows that were returned. So one thing we might want to know about the chunk of rows that is returned is, have we reached the end of the rows, or are there more rows after this? We would probably also want the start cursor, so the unique identifier for the first record, and the end cursor, which would be the unique identifier for the record right after the last record that we returned. And then the end cursor will enable us to fetch more data, another chunk of data in the future. So that's what we want our server to be able to return to the client. So how do we get this from our server? So assuming that your server has some sort of relational database, you'll want to query the database to get these rows. I won't go into all the details of like how you would hook up. In our case, we had to hook up a GraphQL resolver to the database. That will depend on your tech stack. But basically, you want something where you go to the table that you're getting rows from. In our case, we're going to get our rows are going to be employee rows. So you go to the table you're getting rows from. You want to order that table by your start cursor, by your cursor. So created at is the value that I'm using for my cursor. You want to get records that are equal to or larger than your start cursor. And then you want to fetch count number of records. That's in the case that you have the start cursor. That's how you would go to the database to get your next count number of records. If you don't have a start cursor, basically it means you're starting from the very beginning. So you could just order by whatever your cursor is and get count number of records. So that's what the database level would look like. And then after you query your database, all you have to do is basically take those rows that you get from the database and return them to the client. Often I've found the easiest way to get the information I need is to ask the database for one more row than I actually need. So I'm going to say, hey database, here's my start cursor, and give me count plus 1 rows starting from the start cursor. If we assign this to a variable rows, then how would we return this to the client? So we would want to return the rows to the client. We might have to do some mapping or something like that. But the general idea is you would want to return count number of rows to the client. We would want to return if we've reached the end or not. So this is why we're returning fetching one extra row, because if when we fetch the rows, we're able to get, if I'm trying to get 10 rows and I ask for 11 rows and I am able to get to 11 rows, that means I have not yet reached the end. So then this basically, like, if rows.length is equal to count plus 1, then I do have more rows that I can still fetch in the future. To get the start cursor, I just get the unique identifier for the first row. And to get the end cursor, I get the unique identifier for the row right after the last row that I'm returning. And because zero-based index rows that count actually means like the row one after the last row that I'm returning. Okay, so we kind of went to the front end. We said we need to do just-in-time data loading. We went to the back end. We talked about how we would have a back end that supports pagination. Let's go back and talk about how all this is going to tie together. So we were talking about infinite loader and how infinite loader has a couple callbacks. It has the is item loaded callback that asks, is the item at this index loaded? And then it has the load more items callback, which is responsible for fetching more data. When we don't have the data that we need, we invoke the load more items callback. And then that goes to the server and it says, this is my start cursor, give me new rows. And then the server responds with the rows that we need. How do we combine and keep these rows on the client? Because we can't just, whenever we get new rows from the server, we can't throw out our old rows because, like, basically if if I have these rows and then I scroll down, I can't just get rid of these first 2 rows because that would look pretty funny. So basically, we need a way to combine our existing rows with new rows. So if we look at this example, when we invoke load more items for the first time, we'll go to the server and we'll get back in response a page info with like some information about the page, an end cursor, and a rows object with the first 10 rows. Then when we make another request, we'll get back, we'll use that old end cursor, and then we'll get back a new page info with a new end cursor and then some new rows. And we'll want to combine those new rows with the existing rows at least until they're still on the page. And sometime eventually, when our cache gets really big client side, we'll want to clear it out. So one thing that we used on our project that made this really easy to manage was using, instead of like trying to manage this all ourselves, we used Apollo. And Apollo client provides some really good functionality for this. So it basically provides a function where you can make a new query, and then it will combine, you can specify how you want to combine your results of that new query with your existing query. So you can basically write a function that says, take the old rows and append the new rows to it. And then Apollo client will do a lot of the hard work of managing the cache for you on the client side. So that makes it a lot easier if you are using like React and Apollo client and you do have that capability. If not, you still would need to have some way to be able to, you kind of have to manage your cache yourself. When you fetch new rows, have some way to be able to manage holding onto those rows for enough time, but not holding onto them so much that you never clear your cache and crash Chrome. So going back to this example, I'll just kind of talk through the whole thing again. So when we're rendering something right here, we're rendering a cell. And in order to render a cell, we need data to index into. So when we render this item, it basically is indexing into some data that we have on the client. In order to get that data, when we scroll, if we don't yet have that data, so if our callback that says if we have that data or not returns false, we invoke the callback to get more data. And then that callback to get more data goes to the server and asks for more data. The server uses cursor-based pagination or offset-based pagination or something to index into the database, get the correct chunk of data, return that correct chunk of data, and then the client is responsible for knowing how to combine that new data with the existing data. So that's basically full stack, just-in-time data loading. When we implemented this way, we had a lot of success on our project. We did not crash Chrome. And just to recap, some of the main things we had to think about was making sure that we only re-render components when necessary, and that we only render the elements on the screen that the user sees. We had to think about how to set up just-in-time data loading and fetch data in batches as compared to trying to fetch data all at once. And we had to have an efficient backend that supported pagination. And I also want you to remember this next time you go clothes shopping. So when you're in the dressing room, you can think about virtualization and how rendering just a couple items at a time makes for snappier front-end performance. When you are walking around the store and fill your cart with just an armful of clothes, instead of trying to get 100 items in your cart at once or 150 or however many, you can think about how the client loading data from the server incrementally instead of all at once leads to faster performance. And means that it might not even be possible otherwise for the client to get all the data it needs from the server. And as you walk around the store trying to figure out what 10 items to put in your cart next, without wasting too much time, you can think about this GraphQL backend that supports just-in-time data loading and the efficiency of cursor-based pagination. Or you could just have fun clothes shopping and think about this all later. these are the images I used in my talk. And that's all I have. Again, this is a lot of content, and I went over it at a fairly fast pace. So if you are interested in diving into any of these technical details, feel free to check out my blog post on this topic. I go into more of the technical details in everything from front-end performance to back-end, like cursor-based pagination. Are there any questions? I would love to answer any questions if you have any. Or if you've ran into any similar problems or similar considerations, feel free to put it in the chat. I'll hang out here for a few minutes. Okay, so the question is, I know you mentioned this, but what if they've added new items between when I grab page 1 and page 2? Am I going to miss a record? Awesome. So let me go back to that slide. So I think you're talking about the case where if a new record is added from when you grab this page of data to this page of data, would you miss that new record? And as long as it depends where the new record is added. So if the new record was added before your cursor, then yes, you would still miss it. But if the new record was added after your cursor, so if it was added here, I think you would still get it and you would still be good. And the main thing on this slide that I was going for is that if you were using index-based pagination, your indexes would get messed up when a record was added in the database. But in cursor-based pagination, at least your indexes won't get messed up. But if a new thing was added after you had loaded the initial chunk, you still wouldn't get that new thing in cursor-based pagination, I don't believe. We're using, we switched to offset-based pagination, so I haven't worked with this as much, but that is my best guess. Did that answer your question? Awesome. Thanks for the question. All right, I'm going to assume that we're good. Thank you all for coming and for trying out this virtual talk with me. Have a good rest of your evening.